These solar heaters cost me about $10 per square meter to make, and it is 30 times cheaper than these solar heaters of large solar power plants. The materials for this heat storage cost me $50 per water ton, which is 20 times cheaper than these heat storages from shops. It's water with a temperature of up to 80 degrees Celsius is used to heat this house in winter and to heat the water of this pool in summer. This water is heated by solar radiation, which is focused by these mirrors here, and now you will see how I installed these pipes. Then I will describe how the pipes convert the solar radiation into heat in the water, and also I will show you the technical condition of the pipes after several years of operation. I used the cheapest steel pipes, which are designed for domestic water systems. First of all, I covered the pipes with a coat of primer and a coat of regular paint, and later, after the pipes are installed, I will apply a coat of high-temperature paint. The length of these pipes is 6 meters, but I needed 18-meter pipes, and therefore we see electric welding of those 6-meter pipes. Now I am showing the installation of the pipes, and this type of fastening ensures freedom of movement of the pipes as a result of their thermal expansion. This is one of the ends of the pipes, and later I will add this cap. A pump takes this water and directs it here, and then the water goes through the 3 lower pipes which absorb this solar radiation from the mirrors and convert it into heating of the water. Then the water turns around in this way, returns through the 3 upper pipes where it continues to be heated by the solar radiation, comes here and returns to the tank. To understand why the water in these pipes does not freeze on a winter night, pay attention to this check valve, which only allows flows in this direction. Turning off the pump causes the water to completely drain from the pipes into the tank, and the check valve allows ambient air to enter the pipes. And you may notice that the pipes have a slight slope and they are located above the tank. I want to clarify that these pipe connections were a bad idea due to the differences in thermal expansion of the pipes, and therefore I was forced to remake them this way. A few years later, I decided to look at the bottom of the tank, and now we see a thick layer of rust, which a few years ago was the steel of those pipes. I think that the main cause of their corrosion is the oxygen from the air which entered the pipes through this check valve during those water removals, and therefore those water removals were stopped during the spring, summer and autumn months by installing this cap. In addition, maybe I should connect this input to the tank so that the pipes are filled with less aggressive gas from the top of the tank with a minimum of oxygen. The second cause of the corrosion was oxygen in the water, because it was ordinary water from an underground well, not water after deaeration. Now I will show the technical condition of my cheap steel pipes after 4 years of operation. During the first 2 years the pipes were in good condition, but then the corrosion started making these water leaks at the pipe seams, and the corrosion occurred inside the pipes because the outer surface of the pipes is protected by the paint. Usually the leaks stopped on their own due to clogging by rust particles, because the water pressure in the pipes is less than 1 meter of water column, but sometimes I was forced to close a leak by this rubber ring with a clamp. All this is the reason why I have to install new pipes every few years, and I see 3 ways to increase the lifespan of the pipes. Firstly, I can use more expensive pipes, made of more expensive steel or other metal. Secondly, we can take an example from traditional solar collectors, which usually use not water, but antifreeze liquid, which transfers the thermal energy to the tank through a heat exchanger. Thirdly, my drain-back method can be implemented in this correct way, which requires that the water in the pipes transfers the thermal energy to the tank through a heat exchanger, and the pipes are filled with this air and not with the ambient air. I also remind you that my future videos will show the making and installation of other parts of my solar heaters, this heat storage, and possibly other parts of my heating system.